Section 10.1 is on circles and circumference. In fact, all of Chapter 10 is about circles, so before we dive into the chapter, we need to go over a lot of basic information and a lot of vocabulary regarding circles. So the definition of a circle is the set of all points in a plane that are equidistant from a given point, which is called the center. So here we have circle P, and we designate it like this: a circle with a dot and an uppercase printed P refers to circle P, and P is the center. That's how we name it. So in circle P here, all of the points that are on the circle around the outside edge here, all of those are exactly the same distance from the center, from point P. A radius is a segment whose endpoints are the center and any point on the circle. So some examples of radii, and that's the plural of radius, some examples of radii in this circle are segments PE, PC, and PD. And in a circle, all radii are congruent because they are all the same the center is the same distance from every point on the outside of the circle. A chord is a segment whose endpoints are on the circle. So an example of that would be AB. Segment AB is a chord. Also, segment CD is a chord because its endpoints are on the circle. A diameter is a chord that passes through the center. And in this case, CD is a diameter, but it is also a chord because endpoints C and D are on the circle, but what makes it a diameter is that it goes through the center P. And the length of a diameter is twice the length of a radius. And here's a couple little formulas we use for that. So D, the diameter, is 2 times the radius, or we can say that the radius is 1/2 of the diameter. Here's an example. So given this circle, we need to do the following things. Name the circle. Well, the name of this circle, you draw a circle, put a dot in it. This is kind of like the equivalent of drawing a triangle in front of the letters for a triangle. So this would be circle A, and do an uppercase printed A. Name a radius. Actually, there are quite a few radii here. Let's see, AX is a radius. AY is also a radius. AZ is a radius, as is AW. And those are line segments, so make sure you write them that way. Name a diameter. Actually, the circle has 2 diameters, WY and XZ. And let's name a chord. The obvious one would be WX, this chord that goes across the top here. But remember, diameters can also be chords. So WY and XZ. Number 3, if AX is 7, the length of AX is 7, find the length of WA. So AX is a radius, so if that radius is 7, okay, that means actually that all these radii are going to be 7, okay? So then the length of WA is also going to be 7, okay? Number 4, if WY is 18, so that would be all of this right here, so if WY is 18, find XA. Well, 18 is a diameter, XZ is also a diameter, that would also be 18, and XA would be half of that, so the length of XA would be 9. So 2 circles are congruent if and only if they have congruent radii. So if AM is congruent to BN, then circle A is congruent to circle B, and conversely, if circle A is congruent to circle B, then AM is congruent to BN. All circles are similar. So remember we talked back in chapter 4 about chapter 7 about similar triangles. All circles are similar because they are not necessarily the same size, but they are the same shape. All circles are circular, so they all have the same shape. So we would say circle P is similar to circle R. Concentric circles are coplanar and have the same center. So circles that are in the same plane, in this case the plane of the computer screen, and they have exactly the same center. So circle Q with radius QP and circle Q that has radius QR are concentric circles. They share the same center. Circles can intersect in 2 points, 1 point, or none. In this first example, these two circles intersect in 2 points. These two circles intersect in 1 point, as do these, and these two circles do not intersect, nor do these. Here's an example. We have circle A that has a diameter of 22 units and circle D that has a diameter of 16 units, and we're given that BC equals 5, so we need to find the length of AD. So I'm going to label a few things in here. If the diameter of A is 22 units, then I know that this radius is 11, and I also know that this radius is 11. The diameter of D is 16 units, then I know that this diameter or radius is 8, as is, let's see if I can draw it in here, this radius is also 8. And then we're told that BC equals 5. So that's this segment right here. And what I need to find is the length of AD. Well, if AC is 11 and BC is 5, then AB is going to be 6. And let's do the same thing over here. If BD is 8 and BC is 5, then CD is going to be 3. So to find the length of AD, I'll add up all of the little segments that make it up. So AB is 6, BC is 5, that was given, and CD is 3. So the length of AD is 14 units. Circumference of a circle is the distance around a circle. The circumference is really the perimeter of the circle. It's the distance all the way around. Pi is the ratio of the circumference of a circle to its diameter. Pi is a constant, 3.14159, and so on forever. But no matter how large or how small the circle, if you take its circumference and you divide it by its diameter, you always get pi. And here's two formulas you should memorize. The circumference equals 2 pi times the radius, so 2 times pi times the radius, or the circumference of a circle equals pi times the diameter. Notice they're basically the same because 2 radii are the same as 1 diameter. So let's take a look at a couple examples here. Find the radius and diameter of a circle to the nearest hundredth if its circumference is 75 inches. So the circumference of the circle is 75 inches, and I need to find the radius and the diameter. So I'm going to start with one of the formulas. I think I'll do circumference equals pi times the diameter. My circumference is 75. My diameter is what I need to find. So I will divide both sides by pi. Remember, it's just a number. And please use the pi button on your calculator. Don't use 3.14 like you may have done in middle school. Use the pi button. So the diameter is exactly equal to 75 over pi, which, punching that into your calculator, is approximately equal to 23.87 inches. To find the radius, I could just cut that in half or show you how to use the other formula. The diameter equals 2 times the radius. Oh, actually, that is what I'm doing. The diameter is 2 times the radius. So 23.87 equals 2r. Divide both sides by 2. And the radius is approximately equal to 11.94 inches. Okay. A polygon is inscribed in a circle if all of its vertices lie on the circle. So inscribed literally means written in. So this polygon, this pentagon, is inscribed in the circle because all of its vertices right here lie on the circle. And then conversely, or the other way to look at it, is the circle is circumscribed about a polygon if it contains all of the vertices of the polygon. So circumscribed literally means written around. So in this case, we can say that the circle is circumscribed about the polygon because all of the vertices of the polygon lie in the circle, on the circle. And here's a couple examples. A square that has a side length of 8 inches is inscribed in a circle. Find the exact circumference of the circle. So this could be a little challenging for me to draw here. So the square is inscribed inside the circle. I think I'm going to start by drawing the square. Okay, and this is inscribed in a circle. So I'm going to try to draw a circle around this. Actually, that's not too bad. And the square has a side length of 8 inches. So each of these sides is 8 inches. And remember, in a square, all the sides are congruent. Find the exact circumference of the circle. So in order to find the circumference, I need to use the formula circumference equals pi times the diameter, but I need to find the diameter of this circle. It is not 8. Notice, 8 is the side of a square, and that's just basically a chord of the circle. What I'm looking for is this right here. Notice that the diagonal of a square is exactly the same as, a diagonal of the square is exactly the same as the diameter of the circle. And really what we have here, go ahead and mark it, is we have a 45, 45, 90 right triangle. Because remember, anytime you cut a square in half diagonally, you've created a 45, 45, 90 right triangle. One leg is 8, so the hypotenuse is going to be 8 square root of 2. Whoops, I wrote 8 square root of 8. 8 square root of 2, and that's the same as my diameter. So the diameter of this circle is 8 square root of 2. Plugging that into my formula, circumference equals pi times 8 square root of 2. And all we need to do here is just clean this up a little bit. The way we would usually write this is 8 pi times the square root of 2 inches. And that's the exact circumference of this circle. Exact is going to have pi in your answer, and it might have a square root in your answer as well. And our last example says find the exact circumference of this circle. And here I have a triangle inscribed in the circle. Notice it is a right triangle, and notice that the hypotenuse of the right triangle is a diameter of the circle. So again, I need to find the diameter so that I can use the formula C equals pi times the diameter. But this isn't a special right triangle. It's not a 45, 45, 90. It's not a 30, 60, 90. So I'm going to have to use the Pythagorean theorem. So 8 squared plus 12 squared equals, I'm going to call it D since it is the diameter, D squared, or 64 plus 144 is D squared. D squared is 208, so the diameter is the square root of 108, which if you start to factor tree that and simplify it, you will get 4 square root of 13. Plugging that into my formula, the circumference is pi times 4 square root of 13, and putting that together with my 4 followed by the pi, and then we put the square root of 13 after that. And that's my final answer. So make sure that you're up to date on all of that vocabulary we went over at the beginning of this lesson, and make sure you know the formulas for circumference and diameter and radius.